Hi, Assalamualaikum. Today I would like to explain about question 1. Prove that for positive integers p choose 1 equal to p. Let p equal to positive integer, p equal to 2, n choose k equal to 2 choose 1, which is n equal to 2 and k equal to 1. And then we insert the binomial formula and we get 2 factorial over 1 factorial times 2 minus 1 factorial, and the answer we get is 2. So it proves when p choose 1 equal to p, so our p is 2 and the answer is 2. Thank you.
Assalamualaikum and hi, my name is Sikri Atushri binti Muhammad and I would like to explain question number 2, which is by using binomial theorem, find 3x minus 4y to the power of 5. So we are going to use this formula that we have learned in class, and these are the steps on how to get the answer.
So question 3, the following are about binomial theorem and Pascal triangle. So 3a, how Pascal triangle relate to binomial theorem? The coefficient for an exponent binomial in form of a plus b by the power of n, whereas n plus 1 is the triangle law, can be determined using Pascal triangle. This coefficient can be applied to find the complete extended binomial according to the binomial theorem. Question B, give one example for your statement in A. Elaborate your answer. So on the left hand side we have the Pascal triangle, and the right hand side we have the binomial expansion. So now we pick the fifth floor, which is n plus 1 will be 5. So n will be equal to 4. So if we substitute the n value to the 4 and we expand the equation a plus b by the power of 4, we will get 1a by the power of 4, 4a, 3b, 6a by the power of 2, b by the power of 4, 4ab by the power of 3, and 1b by the power of 4. So the coefficient we get 1, 4, 6, 4, and 1. So the conclusion, the coefficient if we expand a plus b by the power of 4 is 1, 4, 6, 4, and 1 from left to right. If we look at the Pascal triangle on the fifth row, which is n equal to 4 and the row equal to 5, we already know the coefficient which will be 1, 4, 6, 4, and 1, which is the same as the binomial expansion.
Assalamualaikum, my name is Nur Hafiza binti Solihin with number metric D2019-2091713. So in this video, I will explain about question number 4 and also question number 5. For question number 4, let A divides B for A and B are the element of integers. Prove that A divides BC. Given that A divides B, where A and B are the element of integers, to prove A divides BC. Let A divides B where A and B are the element of integers, then by using definition of divisibility, we have that A divides B as B equal to A times K, where K is the element of integers. Then BC equal to A times K, where K is the element of integers. Then A times K, we let M equal to K, where M is the element of integers, equal to AM. So we get BC equal to A times M. Hence, by using definition of divisibility, we have A divides BC. So it's proven. So next, for question number 5, let A, B, C, and X be integers with A and B are not both 0 and X is not equal to 0. Prove that if GCD of A, B equal to 1 and X divides A, X divides BC, then X divides C. Proof to show X divides C, where C equal to X times K, where K is the element of integers. This equation we get from the definition of divisibility. So let A, B, C, X, where it's the element of integers, X divides A, X divides BC, GCD of A and B equal to 1. By definition of divisibility, From x divided c, we get c equal to xr, where r is the element of integers. And let it be the equation number 1. And next, for x divided bc, we get bc equal to xs, where s is the element of integer, and let it be the second equation. Since GCD of AB equal to 1, by theorem 4, we have that 1 equal to ax plus by, where x and y is the element of integers, and let this equation be the third equation. Then multiply 3 with c, and then we get c equal to cax plus cby, and this the fourth equation. Then we substitute 1 and 2 into 4, so we get c equal to cax plus cby, and substitute 1 and 2, we get xr times ax plus xs times y. Then x times rax plus sy, then let with k equal to rax plus sy, where k is the element of integers, and then we get x times k. Then we get c equal to x times k. Therefore, by using definition of divisibility, we get that x divides c. Then we prove the corollary trait.
Hello everyone, my name is Muhammad Amiruddin Arif bin Nur Hanafi, and my metric number is D2019-209-1716, and we will be going through to problem number 6 and number 7 together. Let's go to the screen, shall we?
Now here we have question 6. It says that using mathematical induction, prove that 9 to the power of n minus 2 to the power of n is divisible by 7 for all positive integer n. So first thing first, we need to write that down, what was given from the question. So 9 to the power of n minus 2 to the power of n is divisible by 7, where n is equals or greater than 1. We need to be careful here that the question says that it is all for all positive integer n. That means the n value here needs to be greater than 0. So because 0 is not a positive integer, right? Which is why we wrote this. Now there's two steps for improving by using mathematical induction, which is the first one is to show that 1 is an element of S. So you do that by let S be a set of positive integer. So we are going to assume that our n is equals to 1, and we are going to substitute it into what was given from the question. So our n is equals to 1, which is 7 divided 9 to the power of 1 minus 2 to the power of 1, which is 7 divided by 7. And it is indeed in fact that our 1 is an element of S. So by using the definition of divisibility, you can say that 7 is equal to 7k, where k is an element of integer. And we will get our k is equals to 1. So therefore, 7 is in fact can be divisible by 7. Now for the second step, we need to show that k plus 1 is also an element of S. So we will take this part of our divisibility. We just simply substitute n. We simply substitute our n with k here. So by using the definition, by using the definition of divisibility, we will take this part. Let me use another color here. This part of the divisibility into into here. So we will get 9 to the power of k minus 2 to the power of k equals to 7m, where m is the set of is an element of an integer. Now we're going to rewrite it as this. We're going to simplify it so that we can easily subtract this, and we will get 7k equals to 7m. Now, since we are going to show that for k plus 1 here, we are going to substitute k equals to k plus 1. So, just like so, just write it here. So we have 9 to the power of k plus 1 minus 2 to the power of k plus 1, and again we need to simplify it so we can easily subtract the insides here. Just write it like this, and we will get 7k plus 1, 7 to the power of k plus 1. We can again rewrite it like this because we indices, we know that ax plus y is equals to ax times ay. Hence the reason why we do it like this. We write it like this. And since we already have our 7k, we just substitute it 7m. And now we need to factorize the 7, which is 7 times by 7 m times 1. And here is just a number, right? It's an arbitrary constant, right? It's a constant. So we can let m times 1 is equals to L, where L is also a set of integer. Then we have already got our 9 to the power of k plus 1 minus 2k plus 1 is equals to 7L over here. Again, we're not done yet. So by using the definition, again, the definition of divisibility, so 7, we can say that k plus 1 is also an element of S because of what we have done there. We have done earlier, right? And to write the conclusion, therefore, by using mathematical induction, 9 to the power of n minus 2 to the power of n is divisible by 7 for all positive integer n is true. There you have it for problem number 6. Now let's move on to problem number 7. Alright, for problem number 7, we need to find all the solution for xy to the following Diophantine equation, which xy are both positive integer. We need to take note of this particular keyword right over here. So our equation, our Diophantine equation is 11x plus 13y equals to 369. So from here, we need to identify our A, B, and C, which are our A is 11, our B is 13, and our C is 369. So step number one, we need to determine the GCD of 11 and 13. So in order for us to get that, we need to use a Euclidean algorithm. So 13 is equals to 11 times 1 plus 2, which is our reminder is 2, which is not equals to 0. So we keep on going. So 11 here will bring out down here, and our 2 here will bring out down here. So 11 is equals to 2 times 5 plus 1. 1 is our reminder number 2, which is not equals to 0. It's okay. We move on, and we keep on continue. So we bring number 2 right over here, and we take number 1, bring down right here. So 2 is equals to 1 times 2 plus 0. Finally, we have our reminder 0. And we need to stop there. So our GCD of 11 and 13 is 1. And next step, we need to determine that GCD divide C. Now our GCD just now we have 1. So we need to write it as 1 divide 369, which is our C. So from here, we need to use the definition of divisibility. So that means 369 equals to 1m, where m is an element of integer. So our m is equal to 369. That being said, according to theorem number 7, the equation has solution since 1 is in fact divisible. 1 divides 369. So next step, we need to determine the particular solution, which is the x0 and the y0. Yeah. Now, in order for us to find a particular solution, we need to use the backtracking method. All right, which is 1 is equals to 11 minus 2 times 5. Now, from step 1 here, we have 13 is equals to 11 times 1 plus 2. Now we need to manipulate manipulate until the number 2 is right hand side. So we will get 2 is equals to 13 minus 11 times 1 times negative 5. So 11 times 6 minus 13 times negative 5. However, we need to multiply both sides with 369, which is our C here. And we will get 11 times 2214 minus 13 times negative 1845. Therefore, the first value right over here inside the parenthesis is our x0, and the value inside the second parenthesis here is our y0. So thus our x0 is 2214 and our y0 is negative 1845. Next step, we need to determine the values of x and y. How are we going to do this? We need to use the explicit form of theorem number 7. The explicit form of theorem number 7, which states that x is equals to x0 plus b over d times t, where t is an element of integer. So we plug in our values that we have found earlier, and we will get our x is 2214 plus 13t. Same goes for the y, which is y is equals to y0 minus a over d times t, where t again is an element of integer. Plug in our values and you will get our y is negative 1845 minus 11t. However, since our question asks for all positive integer, yeah, both positive integer, yeah, x, y are both positive integer. Therefore, we need to continue and find a solution for the positive integer. Now, one thing about positive integer, you need to know that the value needs to be larger than 0, because 0 is not a positive integer. Hence, the reason why x is larger than 0 and y is larger than 0. So we take our x value that we have found just now, which is 2214 plus 13 is larger than 0, and we solve it in terms of t, and you will get our t is equals to negative 470.31. Excuse me. The same goes for our y value, which is we take what we have found for our y, which is negative 1845 minus 11t, and we solve it, and we in terms of t, and we will get our t is less than negative 167.73. So our range will be looking like this. Let me use another color here. T larger than negative 170.31 and less than negative 167.73. 73. Right. Then we make a number line between those numbers, negative number line, and for the negative 117.31, which is the x value, you should know that it is larger than the value here. So that means it will move to the right hand side of the number line. And for the y value, since it is less than the value right over here, it needs to move to the left hand side of the number line. So we know that from the number line, as you can see, that there is an intersection for value t. That means it has a positive solution. So in order to find that, we need to take the values in this range, and find it for each and every one of the x and y's, and we will have our x1 is equals to 4, our x2 is equals to 17, our x3 is equals to 30, and our y1 is equals to 25, and our y2 is equals to 14, and y3 is equals to 3. And there you have it.